All right, here we go with 4.12. So we're going to begin today with posting your questions to the comment section. So most of you will probably have a question, and that's perfectly fine. Your question needs to be specific, okay? So if your question is, how do I graph a sinusoidal function? That's not specific. You can go back and watch a video and go look in your notes, and you have plenty of help with graphing. Okay, maybe it's specific to the graphing of this function though, and that's perfectly fine, right? So, you might be saying, I found a period of pi. Does that mean that my next maximum value occurs at 3 pi over 2? Something like that. If you don't have any questions, you want to answer one of these questions, you are more than welcome to answer a question, okay? The way that I'm going to keep track is I'm going to look for your tag. Okay, so before you write your question or before you answer a question, you need to put your first name, okay, your first name, then a period, then your last initial, and then a period, and then your actual period number, so which period you're in. Okay, so for example, if I am Nigel Beckles in 6th period, my tag will look like this: Nigel period B period 6. Okay, I'll look on that and I'll say, okay, Nigel Beckles, 6th period, good to go. Okay. Today, I want your question or your answer to be from the last 2 questions that we do, and I'll mention those when we get to them. Okay, so we're going to continue looking at the key features of sinusoidal functions, given graphs or algebraic representations. We're spending a little bit extra time on algebraic representations because that can be kind of tricky. I want to do is just review average rate of change between 2 points. So if I have some interval, let's just draw a graph here. Okay, and here's my function. Okay, so let's say I want to know the average rate of change between this point here and this point here. Okay, so this is the x value of 1, and let's say this is the x value of 2. Okay, so the way we would say this is we want to know the average rate of change on the interval from 1 to 2. Okay, so remember, the average rate of change between any 2 points is just the slope of the line that connects those 2 points. Okay, it's the slope of the line that connects the points. Okay, and that is, of course, the change in the y value over the change in the x value. So here between 1 and 2, let's just say that this happens to be a value of 5 and this happens to be a value of 8. Okay, so if I'm looking here, the average rate of change between these 2 points, well, here the y value is 5, here the y value is 8. So the change in y, I went from 5 to 8, so the change is going to be 3. And the change in x is from 1 to 2, which is a change in 1, so my average rate of change is going to be 3 units. And that is, of course, the slope that goes through those 2 points. Okay? So if I want to find a place where the average rate of change is 0, just think about that. If I want the change in y over the change in x to equal 0, well, what has to be true of a fraction whose value is 0? The numerator has to be 0. So this, if I want this to be the case, that means that the change in y has to equal 0. In other words, I have to be going between 2 points that have the same y value. So here are a couple of functions for us to look at. I'm going to go over A here. So if you haven't finished up A, go ahead and do that on your own, and then move on to B and C. I'm not going to explicitly go over B and C. Those are things for you to ask questions about, either B or C, or answer a question about. Okay, so you want to find the maximum and minimum values, an interval where the function is decreasing, and an interval where the average rate of change is 0. So just for a second, think about how many of these things should you be able to figure out without graphing. So the maximum and minimum values, those are pretty easy to find without graphing our function. We can just, there are certain things that we note about these different functions which will allow us to figure out the maximum and minimum values. The interval where they're decreasing or increasing and where the average rate of change is 0, those are much easier to see if we have a graph. You know, what I want to challenge you to do is to try and figure it out without graphing, and then only go ahead and graph once you've given it some thought. Okay, and I'll talk about that in going over A here. Okay, so go ahead and run through A again. Make sure that you understand as much as you can before you look at the explanation, and then go through B and C and make sure you post a comment with a question or an answer, and don't forget to tag yourself. Alright, so thinking about A here, just looking at this function, I can figure out the max and minimum values. So I know that the biggest value that I could ever get will be 1 plus whatever the biggest value that 2 sine of 3x can be. And I know that sine, the biggest value that I can ever have of a sine, is 1. And so if this is the biggest it can ever be is 1, 2 times 1 will be 2. The biggest that this expression can be is 2. So 2 plus 1 will be 3. My maximum is going to be 3. Where does this come from? This comes from looking at the amplitude and the midline. Okay? So my amplitude for part A is 2, and my midline is the line y equals 1. And the amplitude, of course, tells me, okay, how much higher can I go than the midline, right? The maximum I can go is 2 times 1. And what's the lowest below the midline I can go? Well, the minimum value of sine is -1. 2 times -1 is -2. So I could go -2 or 2 below +1. So the maximum, these two things here tell me that the maximum is going to be 3, and the minimum is going to be -1. At this point, I'm probably going to want to go ahead and sketch a graph of my function in order to figure out the other two pieces. So in order to do that, I want to also consider the period, which is 2 pi divided by the absolute value of b, which is 3. So period is 2 pi over 3, and there is no phase shift. Okay. Now, to actually graph this, there are a couple of ways that I can do this. Okay, I can start to just think about where's my first maximum going to occur, what does a sine function look like, and then I could go ahead and sketch the graph of the function. Or I could just start plotting some points, making sure to find my first maximum and going from there. I'm going to go over both ways. So if I'm just thinking about the way that a sine function looks, I know that if there's no phase shift, the sine function is going to have an initial value at its midline. So its midline here is 1, so the initial value should occur at 1. Okay? Now I know that sine, positive sine, starts at the midline and starts to increase. So I know it's going to increase, and it's going to increase until it gets to the maximum value. So I want to then ask myself, where's the maximum of this function going to occur? And that's going to happen when sine is at a maximum. In other words, when I have sine of pi over 2, because that's where the maximum is. So I need to figure out how will I make 3x into pi over 2, and I get that x will have to be pi over 6. So I know that the maximum is going to occur at pi over 6, and I know that that is a value of 3. Okay? Now, I know the next maximum is going to occur 2 pi over 3 units to the right of that. So I could then take pi over 6, and I can add 2 pi over 3. So if I have pi over 6 and I add 2 pi over 3, I'll let you work that out on your own, but you're going to get 5 pi over 6. So I'm going to have another maximum there. Okay? Now I know that in between those 2 points, in between pi over 6 and 5 pi over 6, I'm going to hit a minimum. Well, what's in between these two values here? If you think about it, this is pi over 6, this is 5 pi over 6. So there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Halfway in between is going to be 3 pi over 6, which is exactly pi over 2. That's where my minimum is going to occur. So now I can really start to look at my function like that. Okay? Now, that may be a little bit advanced for you, and you may be a little lost in some places. You'll get to that point. If we're not quite at that point, we're going to go ahead and make an XY table and think about some values. So starting at 0, plugging in 0 here, 3 times 0 is 0, sine of 0 is 0, 2 times 0 is 0, plus 1 is 1. So my initial value point is at 1. And now let's say I move on to pi over 2 here. Now when I plug in pi over 2, 3 times pi over 2 is 3 pi over 2. Okay? So sine of 3 pi over 2 is negative 1, 2 times negative 1 is negative 2, plus 1 is negative 1, which is exactly what I found, right? But here you'll notice you can't just go from this point at 1 to the point at negative 1 because sine should increase. So I need to find the maximum that occurs in between these two, and so now I'm back to the same situation where I'm looking for what is going to make sine its maximum value of 1. Well, that's when the input is pi over 2. I know that I'm taking 3 times x to get my input, so what will make 3x equal to pi over 2? I multiply by 3, or divide by 3 on both sides to get x is equivalent to pi over 6. So here I would say, okay, I need to graph pi over 6. That's going to be a maximum of 3. And so that's where I get my maximum value. Okay, and then from there we can use the period of 2 pi over 3. I have my minimum and my maximum. I can find another min and another max. Okay, so now that I have this graph, I can go ahead. I have my max and my min here. And now I need to find an interval where the function is decreasing and an interval where the average rate of change is 0. So first, where it is decreasing, if I look from pi over 6 to pi over 2, that is clearly a negative slope. So that's decreasing. And so I might say that where it is decreasing between pi over 6 and pi over 2. Okay? Where is the average rate of change? 0. So that will be between 2 points where the y value is the same, the change in y is the same. So we could use a couple of different points. I could go between pi over 6 and 5 pi over 6. But I could also go between 0 and, let's just go all the way over here, between 0 and pi, for example. It appears as though there is 0 average rate of change. Okay, so that'd be another one. All right, moving on, you're going to go ahead and look at B and C and do these on your own. I will say that for C, it's helpful if instead of using this type of graph, if you actually count by integer values, that will be more helpful for you. Okay, don't forget to post a question or an answer, and don't forget to tag your name so that I can give you credit for it.